Math 30 Pre-Calc. This is Chapter 2 and radical functions, and we're going to start with the functions and the transformations. So what we have to see first here is that there is a base function, and the base function is y equals the square root of x. And you're going to get to know the base functions of various other ones. You already have learned in Math 20 y equals x squared, and you learned all the characteristics of that, so we're just continuing on with that. So the first thing we notice to the right here is the graph of y equals x. So when we talk characteristics, we always talk intercepts, we talk domains and ranges, and if necessary, turning points and such. But if we take a look right now at this one, we can take first at the x-intercept, and we see the x-intercept is 0, 0. The y-intercept is also 0, 0. So that's this point right here. So that's your x and y intercept. Now, let's take a look at the domain and range. We'll first start with the domain. Now, the domain of this graph shows us that it starts at 0 and the graph goes right. There are no x values to the left of the 0. So we would say the domain then is x such that x is greater than or equal to 0, x element reals, or, which is nicer to write, the interval is like that. So that's saying it starts at and can equal 0 and it goes infinity positive. Now the range for this one starts here and the graph goes up. It doesn't go down past 0, but it keeps going up. And if you follow this line, it will just continue on its upward direction. It might not look like after a while, it might look like it's flat, but it is always moving up. So it's going up. So what we have for the range is y such that y is greater than or equal to 0, y element reals, or again an interval. You can do it like that. Okay, so those are the base characteristics of y equals the square root of x. Now we're going to put some transformations to them. So some of the transformations, if we remember, there's translations, which are shifts right and left, and there's the reflections, and then the stretches. So let's take a look at the first one here. It says, use a table of values to sketch the graph of each function, then state the domain and the range. Okay, so what I'm going to do first is find the restriction to help me start my table of values. So we take a look and we know that x minus 2 has to be greater than or equal to 0. Because if it's any less, you can't find the square root of a negative number. So that means x greater than or equal to 2. So I would start my table at 2. I'll go 3. I'll go 6. And I'll go 11. The reason I chose those ones was so we can graph it easier with when we subtract and we don't get some strange numbers. Okay, so now what I will do is I will do the work. 2 minus 2 is 0. So I just replace the x, and 2 minus 2 is 0. The square root of 0 is 0. 3 minus 2 is 1. The square root of 1 is 1. So what we had here was the square root of 2 minus 2 equals the square root of 0, and that's why the 0 is there. The next one was 3 minus 2, which is the square root of 1, which is 1. Then 6 would look like this. 6 minus 2 equals 4. The square root of 4 is 2. So that shows you why I didn't choose other numbers, because we wouldn't get a nice even number. You can still put other numbers, it's just for graphing purposes. And then we have 11 minus 2 is 9. The square root of 9 is 3. So now we take those points and we will plot them. So we're going to plot, the first one is at 2, 0. The next one is at 3, 1, 6, 2, and 11, 3, and we draw our graph. So we can see this graph has shifted to the right 2 units, which makes sense because if we recall our transformations, what we have here is, in this particular one, if we have y equals x minus 2, therefore h equals 2, which is a horizontal shift to the right, and that's what we have. Okay, the next one, we will first find our restriction, and x greater than or equal to 0. We just look what's underneath the radical sign, and that becomes our restriction. We make it greater than or equal to 0, and we solve. In this one, there was x minus 2 under, so we had to do some math. This one is just x has to be greater than 0. So those are the numbers we will use. We'll start at 0, and I'm going to use 1, 4, and 9, because those are perfect squares. So we have the square root of 0, which is 0. We have the square root of 1, which is 1. The square root of 4, which is 2. And the square root of 9, which is 3. So that gives us our points. So now we graph those points. 0, 0. Oh, sorry. I have to change those, because I forgot the minus 3 on all of them. So this one here would be negative 3. The square root of 1 is 1. 1 minus 3 is negative 2. The square root of 4 is 2. 2 minus 3 is negative 1. The square root of 9 is 3. 3 minus 3 is 0. I had forgotten this when I did it. So that makes a little more sense. Now we'll plot those points. So the first one is at 0, negative 3. The next one is at 1, negative 2. 4, negative 1. And 9, 0. And we join the points, and it would look something like that. So we notice this time, if we look at our y equals a f of b x minus h plus k, and this one here is y equals x minus 3, what we have is k equals negative 3, which means it will shift down 3 units, which it did right there, shifted down the 3 units. Because we know it is a radical function, that's why we don't have the f out in front. And we can write it as that radical function of the square root of x. Okay, so that's how, one of the ways you can graph, given the function, what you can do to graph, use a table of values. So right now we're asked to write the radical function that results from applying the following transformations to the graph of y equals f of x. So what we need to do then is identify each of our parameters. If it's a vertical stretch, that's the letter A. So vertical stretch by factor of 2. That's what that would be. So a equals 2. Horizontal stretch by factor of 3. If we remember, b then would equal 1 over 3. And we have to remember that b has to be less than 0 because of our next point right here. It's reflected in the y-axis. That means that it has a horizontal. It's going this way. It's reflecting horizontally over the y-axis, not the x-axis. So that's the way it's flipping. So that means it's a horizontal, so that means b is negative. We're told there's a translation of 4 units left. So left, right is horizontal. 4 units left would be negative 4. And k, which is the up, down, the vertical, and it says 1 up, so that's positive 1. So we now remember our f of x equals, well, I should maybe write it up here. First, to remind us, a f of b x minus h plus k. So f of x equals a, which is 2, f of b, which is negative 1 over 3. Don't forget we said b has to be less than 0. And this becomes x plus 4, and then plus 1. X minus h, x minus minus 4 equals x plus 4. That's why that's plus 4 under there. Now, what we will do is we were told to write it as a radical function. So let's write this now as the radical function, not just as some function. So what we will have then is, therefore, y equals 2. Now, rather than putting the f there, I put the radical sign. And what goes underneath is what's in the brackets after the f. Negative 1 over 3 x plus 4. And then the k value is outside. So that is it written as a radical function. Okay, so that's what we were asked there to do. And we're going to come back to that one in a second after we do some other stuff here. So graphing radical functions now. Now we're going to graph them using the transformations. We're not going to use a table of values. So what we do first is we have our base function here, this y equals the square root of x. That's the function, that's the graph we see. So now let's identify our parameters. A equals negative 2. B equals 4. Now it's important to remember this one, we'll go back to it. H equals 3, it's positive 3. And then k equals positive 1. We need to remember that it's x minus h. So the h has to be 3 because everything else lines up. So the stretch and the reflection go first. Translations. So here we had our stretch reflections. We have that it's going to in front of the x value. Let's just do it this way. We'll say that a equals negative 2 and b equals 1 over 4. H equals 3, k equals 1. So now let's put that into our mapping. So we need to map this. So the horizontal ones go with x. That's the b and the h. Those are the horizontal ones. So we are going to have 1 over 4x plus 3. And the vertical are the a and the k. And we'll have negative 2y plus 1. So now that's our mapping. we're going to take points from the original. That's the one that's on here already, and this is the one you're going to have to just know. So the first point is at 0, 0. So the first point is at 0, 0. The square root of 0 is 0. The next one is here up to there, so the square root of 1 is 1. We'll go all the way over to 4. The square root of 4 is 2, and the reason we picked 4 is because it's a perfect square. So obviously the next one we'll take is 9. And the square root of 9 is 3. And we could keep going. Let's do one more. 16, square root is 4. And you could do 25. You could just do all the perfect squares. And those are the base points on the base graph. Those are the key points on the base graph. So now we're going to do the math on them. 1/4 x, so 1/4 times 0 plus 3 is 3. -2 times y, which is -2 times 0, plus 1 is 1. And what you should notice is because it is the origin, these values are your h and k values like we discussed previously. Now we'll do the rest. 1/4 of times 1 is 1/4 plus 3. That one comes to 3.25. -2 times 1 plus 1 is -1. 1/4 times 4 is 1. 1 plus 3 is 4. -2 times 2 is -4 plus 1 is -3. 1/4 of 9 is equal to 2.25 plus 3 comes to 5.25. 3 times -2 is -6 plus 1 is -5. And the last one would be 1/4 of 16 is 4 plus 3, that would be 7. And -2 times 4 is -8 plus 1 is -7. So there are the points. So now let's take a look at what the transformed graph looks like. So we plot the points in the right column, the transformed points, okay? Those aren't the key points, there are transformed points. So we're gonna go to 3, 1 first, right there. Oops. 3, 1 right there. And then our next point is 3.25. Sorry, I have that one in the wrong spot. It's 3, 1. It's right there. The -3.25 at -1. So just kind of guess where it goes. 4, -3. These are sketch. These graphs are sketches. They're not exact. We try to be as exact as we can. 5.25 to -5. About there. And then 7 to -7. And now we play connect the dots. And the graph would look something like that. So that is what the transformed graph looks like. Now, by looking at the graph, let's fill in the details here. So we see on the original graph, we already know what the domain and the range are. The domain, if you want to do it in set notation, or if you want to do it in interval notation, that one would be, as we talked about before. And the range is y greater than or equal to 0, y element reals, or 0, infinity. That's that main one that we talked about right here. Okay, that's the base graph. So that's the black graph. Now let's look at the blue one. We take a look at the domain, Now it looks like the domain starts here at 3, and then the graph, even though it's falling towards the right. So our domain on this one is x such that x is greater than or equal to 3, x element reals, or, and soon I will just use this notation, it's 3 up to infinity. Now this one's a little different. It starts at 1, but it drops down to infinity. So the way we show this range would be like this. Y is less than or equal to 1, because it's at 1 and it drops down, so it's less than y element reals. Or the way we would do this one is negative infinity all the way up to 1. We go from lower to greater when we write in the interval notation. So that's why the negative is first up to the 1, and the other one, the infinity positive zeros to the right, and 3. So that's what we do there. Okay, so now we see this. We need to take a look at a few things here. We notice that this one here had a vertical reflection. And because of that vertical reflection, it affected the range. Instead of the range going up like it does on the base here it's y, goes up, it's greater than. All of a sudden we have it over here as y is less than. So if there is a reflection, it changes the sign in either the range or the domain. Which brings us back to this one. So if I asked here for the domain and range on this one, we don't have to graph it to see it. Notice here that we had a 3 and a 1, and that we have a 3 and a 1, our h and k values. So those will be our domain and range values, whatever they are. In this case, h was -4 and k was 1. So the domain would be looking like this. X such that x and the other number is -4. Now we have to decide, is it greater than or is it less than? Well, because we were reflected in the y-axis, that's a horizontal reflection. Okay, that's this one here we talked about, that horizontal reflection. Because there's a horizontal reflection, x will be less than or equal to -4. X element reals, or if you want to put it in the set notation, it goes negative infinity to -4. That would be your domain. And the range, in this case, y such that y and the range value is the k is the 1. Because there's no reflection, this one will be greater than or equal to y element reals, or 1 to infinity. So we can get our domain and range from our h and k value. If you notice, in the base, this would be written, the base one would be y equals x plus 0 plus 0. H and k are 0, 0. And we have 0, 0 down there. So that's where those come from. Now, here's another one. Use transformations to sketch the graph, identify domain and range. So it's very similar to this one. Oops, this one. So we do everything the same. Let's identify our h and our k values, or all the parameters for that matter. So we are going to identify a, b, h, and k. A is 4, b is -2, h is -3, and k is -5. Now, I'm going to go ahead and do the domain and range before we even graph it, because we can. So the domain on the base graph, we already know, is 0 to infinity. Whoops. 0 to infinity, and the range is 0 to infinity. What we notice here, though, is our h and k values are -3 and -5. Now I'm going to do it in set notation first, just to get comfortable with it. So x, such that x and the number that goes with it is -3. So we have to figure out, do we have a reflection of any kind? And if we do, is it horizontal or vertical? Well, I see b is -2. That means we have a horizontal reflection. So that will affect the domain for the horizontal, or for the x. So it's not going to be, as we normally put x greater than or equal, it's going to be less than or equal to -3. X element reals, and we'll check it when we do the graph. And our range, y, such that y and -5, and we have to decide greater than or equal then. Well, there's no reflection vertically, so it'd be greater than or equal to -5, y element reals. And again, if you wanted to do it in the set notation, this one here would be, it says x is less than or equal to -3, so it'd be -infinity to -3. So that's showing it's going all the way down. And our range in this case would be from -5 and it goes up. So there's our domain and range. Now let's just graph it and let's just verify everything. Again, we have our base points that we're going to use: 0, 0, 1, 1, 4, 2, 9, 3. We just take perfect squares because it's easier to find the y value. If you want to go 1, 2, 3, 4, you're going to have decimal values in there. So just pick values that are good, and usually I will give you those values. Now, we have a equal to 4, and the factor we're going to, with the b, we're going to use -1/2. H is -3 and k is -5. So let's map it. It's going to be -1/2 x minus 3. And it will be 4y minus 5. That's our mapping. We need to remember how to map these. We take the first value here, it's x. So those are the x values. These are the y values that we're going to use, and we map them right into our mapping. So -1/2 times 0 minus 3 is -3. 4 times 0 is 0 minus 5, h and k value. -1/2 times 1 is -1/2 minus 3 is -3.5. And 4 times 1 is 4 minus 5 is -1. -1/2 times 4 is -2. Minus 3 is -5. 2 times 4 is 8. Minus 5 is 3. And -1/2 times 9 is -4.5. Minus 3 is -7.5. And 3 times 4 is 7. Oh, sorry, 3 times 4 is 12. Minus 5 is 7. Okay, so let's plot these points. So the first one is at -3, -5, and the graph is just a little not quite big enough, so it's about there. -3.5, -1, -5, 3, and -7.5, 7, and again, not quite high enough, but that's what it would look like. So there's our graph. Now, domain and range. We already know that the domain of this one are these values. We said, when we did this before graphing, we said x will be less than or equal to -3. Well, it starts at -3 and it goes this way, it goes left. The graph goes left, so that one works. And the range is greater than -5. Well, it starts at -5 and we can see it goes up. The graph goes in an up direction. So we had them right. So you can find domain and range without graphing. Use the HK values. So what you need to know from here are the key characteristics of the base graph. Understand you can use a table of values to graph them, and this was to show you that the H and K value will move that graph, and it also affects the domain and range. Using your language of transformations to come up with the equation, and then graphing it using the transformations and being able to find the domain and range. Okay, here's the work for you. I think I've mentioned, if not though, if you see this 0 after, that is not the letter 0. That means you will look and do the odd letters in the question. So 5A, C, E, and how many ever there are. That's what the O's stand for, the odd letters inside the question. Okay, good luck with that. Any questions, you guys let me know.